So good evening, everyone. Today we're going to talk about VPC, which stands for Virtual Private Cloud. As you know, AWS is a cloud, right? It's a public cloud, but inside of the public cloud, you need to have your own network, right? And so we want to learn this service called VPC. It's one of the most important AWS services. When you join the company and you start working, most companies already have their VPC set up. But if you need to create a new VPC, it's good for you to know how to create a VPC, what a VPC is made of, and how the components work. Okay, if we just go first here, let's do some basic networking. Let me just explain to you how you get internet into your home, right? Let's just do a little refresher. We know what the OSI model is, the 7 layers, right? Right? We know what are the layers? What are the 7 layers of the OSI model?
We got physical layer, data link layer, network layer, transport layer, session layer, and
The physical layer. What's the
yeah,
next? What's the next layer after the physical layer?
the physical layer. After the physical layer, you got your data link layer,
Okay, then what else?
and after data link layer, you got a network layer.
Okay, hold on. After the network layer,
You got a transport layer,
okay. After the transport layer, what's the next layer?
you got session.
Let somebody else speak first. Anyone else?
Session layer,
Okay, continue. After
mm,
session layer,
presentation layer,
1, 2, 3, 4, 5, 6. That's
and
not correct. Sorry, hold on. Yes, presentation. And then after that,
application layer.
okay. Yeah, this will come in your interviews, right? So don't forget that. Application is the final layer. And traffic goes how? From here, when traffic is going out, let's say you're sending an email, it goes this way, right? It goes in this direction. It goes up like that. The traffic goes up when you're sending a request. Sending a request. Let's just send, for example, sending a request is an email address, right? Right, it could be an email. And then when you want to save a file, right? Let's say you want to save something. Um, the response coming back, right? Email sent. So this is basically a network. So moving away from this, you live in a city, and this city is called Dallas, right? In Dallas, you have something called ISPs, which are the internet service providers, right? These guys buy the net, they own the towers, those antennas that sit on top of the mountain, on top of those tall buildings, right? So these ISPs are Spectrum, Xfinity, all those people, right? Those guys, right? So now when they have network servers, what they do is they create they create something called a wide area network, right? So in Dallas, you have different counties and different zip codes. So you have different zip codes. For example, you have 75240. This is the zip code, right? Seven five two four zero. Then you have another zip code like 75810. These zip codes exist in here like that. So these service providers come to this zip code and they create something called a wide area network. Wide area network, a one, right? A one. So when you have a one in that area, if you live in this zip code, they have a one. And then now when you buy internet from when you buy internet from when you buy internet in this zip code, you live here, buy from Spectrum. From this one, this one is bigger. Okay. The one is in there. It's up here, right? This is the one, wide area network. So from here, they'll sell you internet, right? But they'll put you in something called a local area network. That means your quartier, your area, right? Your area. So you'll be in this local area network. From here now is where now you connect to. From here, you connect to this one LAN is inside this one. From here, you connect to this wide area network, and this wide area network connects to the internet service provider. And then you're in here. That's how you receive network. So look at it in a sense, it's like this: LAN, and then bigger. One, and then bigger. You have the internet service providers. You have the internet service provider, which is like Spectrum and those guys. Like that. Spectrum Internet. That's how it is. That's how they break it down. That's how they distribute it. So these guys. And then this guy connected this guy. Okay. So that's how internet comes. Then you have your router in here. You have the router, your modem, and then you connect to the Wi-Fi and everything. That's how you get internet. Okay. Any questions here? The router is what takes internet from the LAN and brings it to your house. Every house that has internet has a router. Okay. Routers back in the day are these things. If you look at a router, they look like this. You guys have a router in your house, right? Over time, they have gotten smaller and smaller and more portable. This is what brings internet to your house. So if your internet is acting up, it's slow, it's not stable, you can do is reset your router. You unplug it from the wall, wait 10 seconds, you plug it back, you take about 1 minute, you come up, and your internet connection will be refreshed. This is what's called a router. Now, your router also connects to your modem. The modem is what gives you connection While the router is what routes the connection from the modem to and gives you internet. The modem is what the spectrum and that's what they give you, right? So you have two devices in your house. You have a modem and you have a router. Some people that have wired connection in their houses don't have a modem, they just have a router. Okay? Any questions there on how you get internet? So in the business, in companies, they have a network servers, right? They have the servers, network servers in the data center. Most companies have a small data center that they have their network servers in there. It looks like this. Most companies have it. You see these huge servers. This is where they receive their own network because they have a business to run. They don't use the same speed that we run. They use huge amounts of speeds, like 10 gigabytes per second, right? They have their own data center room like this. So internet comes into this room, and then using wired cables, it goes to their systems. Any questions in here? Any questions so far, guys, or are we good?
No question.
Okay, good. So let's talk about what VPC is. So we're going to learn what virtual private cloud is. We're going to learn what a public IP address is, a private IP address is, and an elastic IP address. This, I will say this is the most important topic of the VPC. I will ensure you or encourage you to learn what these three different things mean, because on the job, you will deal with this a lot. And the public and private subnets are the two most important things that you need to really know. And then maybe security groups as well. So these IP addresses, subnets, and security groups, I will advise you to really, really master them. We're going to do some practice today, and I'll do more theory on Wednesday, but I'll advise you to really, really go deep, because that is the master key for everyone in the working as an SRE. Okay? So let's begin. Again, this is the OSI model. The physical layer is and you have the data link layer. Here is the physical wire cables, Ethernet. You have the network layer, right? Here is where the IP address is generated, and the IP address is now connected to the transport layer that does the transportation of packets over the network. As we know, TCP is a favorite protocol that we want to use, because TCP is secure, reliable, while UDP is not reliable. So know the difference between TCP and UDP in your interviews. And then the session layer is when the connection is established, the session begins. And when the session begins, it transmits the data in packets. Computer understands data in zeros and ones in binary format. So here the session layer has to be converted into a presentation layer. So the presentation layer is a protocol. We have HTTPS that's why we're able to see things. And then it's presented to the system, and then the computer now converts it to application, and then we're able to see. So you hear of layer 4. The issue is that layer 4 means that what? Which layers are on the client side? Which layers on the client side?
Physical, the first layer, second layer, first, second, and third.
Okay. Which layer is on the server side?
4, 5, 6, 7.
Try again.
No. Sorry. 4, 5, and 6.
Try again. Anybody else want to try?
Yes. It's 5, 6, 7.
5, 6, 7. The transport layer is in the middle,
Ah, yes. Yes.
right? The layer 4 is in the middle. This is what connects the server to the client. This is where everything transmits. The layer 4, when they said this is a layer 4, it means that it's not on the server, it's not on the client, it's on the network. Okay? Take note of that. I've done OSI model a lot. I will advise you guys, if you forget what the OSI model is, just go on YouTube and watch it, guys. Please, this is very important. This question about what the OSI model is will not come from a technical. Let's say you have an interview and you have 3 rounds. The first one is the hiring manager, which will be your boss, right? The second round is going to be a technical interview, which will be your coworker or your technical lead. The final round is going to be a leadership interview, a cultural fit, which you'd speak to a director of the company or vice president of the company who wants to see your character, your behavior, to see if you're sane, you're not in, the hiring someone that has a clear mind, because some companies have hired some people without leadership interviewing them, and they hired some serial killers and some crazy people that hack the company and do some crazy stuff. So the only reason why the leadership people want to talk to you, the VP want to talk to you for 30 minutes, is just to see what your state of mind is. That are you a crazy person? Are you a normal person? That's the only reason why. Once you pass the hiring manager interview and the technical interview, your chances of getting that job is almost at 80%. Trust me, guys. When the director wants to speak to you, they don't want to speak to you to see how much Python you know or how much Terraform you know. No, they want to just see if you're mentally sane. Because some companies like Netflix have hired some super smart people, and those people who had mental serious issues, and they exposed the company to hackers, and serious issues happened. So when you speak in those final interviews, show them that you're a stable person, you're married, you have a family, you have something going on in your life, right? Jobs like to hire married people because married people are stable, right? You have something to look after, you have kids to look after, so they'll keep you hired, they'll keep employing you because you're gonna keep coming to work every day. So, what was I going with that? I was trying to say that the only person that will ask this kind of question is the hiring manager, the first interview. He wants to see if you know computer science. It's not about SRE, it's not about cloud engineer. He wants to just see if you know computer science, because this is something that they teach in school. This is something that they teach in universities. When you do computer science, it's very basic. Everyone who is in computer science knows this. So VPC terminologies you're gonna hear a VPC subnet, you're gonna hear a route table. The route table that you see here is the same as a router that is in your house. The route table in VPC does the same thing as a router. It just directs where connection goes. If you want to connect from your house to AWS, the router will route your connection from your house to AWS servers where you connect. In AWS, they also have a router that's configured to receive connection from your client, which is Firefox, to the VPC. So everything that has network has a router. Even in your router, in your house, you have a route table. If you go to your accounts, your Spectrum accounts, you log into your account, you're able to see your route table. When you look at your route table, you will see all the connections coming to the internet in the house. I have it as well. I have about 20. You'll see all the devices that are connected to the internet when you go to your route table. Everybody has it. You have it in your house as well. Elastic IPs are static IPs. Again, this is something you should write down. Elastic IPs are static IPs. They do not change. Because when you restart an EC2 instance, when it comes up, when you restart and it comes back up, or it comes on with a brand new IP address every time. So some applications that are static, like restaurant menus, in restaurant, the menus, these applications are static. Those menus are static. Those menus are there. When you go online, you look at the menu is there. The menu doesn't really change. So they use an elastic IP with those menus so that when they restart the server, when the server comes back up, the menu, the IP will still be the same. And you can connect to it and look at the menu, right? And you can also configure that menu to show up on Yelp or Google or Open Table, those reservation things for restaurants. So all of that is there. So I said that to say Elastic IPs will always be static. They're very expensive. In AWS, we use them to create EC2 instances that we don't want them to change the IP addresses. We attach Elastic IPs to EC2 instances and use those EC2 instances to create applications that are static, like restaurant menus and things like that. Internet gateway, you're going to hear is a term that we're going to talk about deeply. It just exposes the VPC because this is a virtual private cloud. It opens a VPC to the internet. Okay? And then the VPC NAT gateway is a network address translation gateway that we're going to see. And when you have a private subnet is simply a network space that has no connection to the internet. If you attach an internet gateway to a private subnet, you have made that subnet public. Internet gateway is simply what makes a subnet public, meaning that you can connect to it using a public IP address. A VPC NAT gateway is attached to a public subnet because a VPC NAT gateway makes a private subnet connect to it because the private subnet needs to have some access to the internet. We'll talk more about it. And we'll also learn about network ACLs. We don't really use this very much in the industry. We don't use this very much. And then security groups, we use it very, very heavily. We use security groups very, very heavily. Okay? So let's begin. A VPC is simply enables you to launch AWS resources into a virtual network that you've defined. Keyword that you've defined. In AWS, you have in AWS you have in AWS you have a custom VPC, right? That the custom is the one that you create and you customize it. Whereas you also have a default VPC that comes with your account. A default VPC comes with your account. Okay? A default VPC comes with your account, and that's what AWS uses to really manage your account. So do not delete the default VPC. Okay? This virtual network closely resembles a traditional network that you operate in your own data center with the benefits of using the scalable infrastructure of AWS. Okay? That's what a VPC is. It's simply a virtual network that you can define. You can say, okay, this network, I want it to have 250 IP addresses because I'm going to have 250 customers. You can define it yourself, which we're going to do. So this is the VPC diagram. Please pay close attention. A VPC is your own network in Amazon Cloud used as a network layer for your EC2 instances. Whenever we create EC2 instances, we've always created it inside of a VPC. Okay? We've always created inside of a VPC, and inside of that VPC, you have a public and a private IP address, right? So a VPC is simply just a network layer that you define. You see this box here, VPC, this whole square box, VPC, is a network layer I've defined. Now, the VPC that I've defined in this particular picture that you see is a VPC of this SATA block range. Let me stop. I just mentioned the word CIDR. What is CIDR? CIDR. CIDR. Classless interdomain routing. That's the meaning of CIDR. That's what we call CIDR. I'm going to go into IP address explanation. CIDR means classless interdomain routing. So this is what, when you say IP address range, this is what we mean. So this is an IP address calculator. I can put it in the chat for you guys if you need to use it. So a VPC needs to have a certain number of IP addresses. A VPC is a network that you define in Amazon Cloud as a network layer for your resources. As you guys know, when you create an EC2 instance, the EC2 instance comes with an IP address. But where does it get its IP address from? Every VPC that you create has a CIDR block range. What is a CIDR block? This is a CIDR block range. I'm going to explain. Let me go to the board. We use this to calculate how many IP addresses are going to be in a CIDR block range. 172.31.0.0/16 gives us how many IP addresses? 65,503. 65,536 IP addresses. This is what a typical VPC looks like. Okay? That's the number of IP addresses that are in that network layer. Now, in AWS, there are 3 types of VPC. Only in AWS, only. In AWS, there are 3 types of VPC ranges. Class A is 10.0.0.0/16. Class B is 172.31.0.0/16. Class C is 192.168.0.0/16. And these are the only blocks that AWS has paid money. AWS has paid money to the government that these 3 IP address blocks. This is a block, guys. Why is this a block? This is a block because this block has 65,536 IP addresses. This block as well has the same number as well, 65,536. And this block as well has the same, 65,536. You guys, you need to ask me questions in this particular topic. I need to make sure you're understanding it. If you ask me a question, you'll know that it will let me know what you understood. Amazon has reserved these IP addresses, these IP blocks. So each AWS account that you have comes with this default range. This is the default. So if you want to create a custom VPC, you will use this or this. Or you can still use this as well. But when you use this, you will make sure that it doesn't overlap with what is already there. Okay? So if you look at this diagram, you have your VPC right here, default VPC, right? This one right here, /16. And in the VPC now, VPC is just the internet. It's just the network. We need to separate it into subnets. A subnet is just a private space or public. It could be private or public, right? A VPC is just a network, and then the subnet is like a space within the network, like an intranet, like a private internet or public internet. In this case, it's public. So we have two public spaces here. We're going to create right here. Where you see this right here. We're going to create, sorry. We're going to create a subnet here called default subnet 1. And we're going to say 172.31.0./20. Okay. And then we're going to create another subnet, default subnet 2. I'm going to call it 172.173.16/.0/20. Now, let me explain. In IP addresses, 172.31.0.0, this is the beginning of this address. This is the beginning of this address. If you define a /16 here, that means you're going to have 65,000 IPs. Now, the space from that to the next address, you have to give space in between 172.31.16.0. Let me start over. Whenever you see, or in IP, in networking, 172.31.0.0/16 gives you 65,000 IPs. Yes? Okay. Now, this is your VPC. Your subnet, which is a space inside of this VPC, is going to come with a higher number in this slash right here. These first 4 digits are called what? These first 4 digits are called a net mask. They're called these 4 digits here. This /16 is called a net mask, right? But that's not important. What's important is that under this VPC, because the /16 is really this large, you want to have a subnet under this of a 172.31.0.0/20. But hey, Debo, why are we going higher? The higher your net mask, right here, this /20, the lower the IP addresses. The lower the net mask, the higher the IP addresses. If you go to this calculator and you do a /20, see, right now we have 65,000. If you go do a /20, you have 4,096. The higher you go, if you do a /24, you have 256. If you do a /28, you have 16 IPs. If you do a /32, you have 1 IP. And that's it. That's the highest you can go. Okay? So the higher the net mask, the lower the IP addresses. The lower the net mask, the higher the net mask, the lower the IP addresses. The lower the net mask, the higher the IP addresses. The higher the net mask, the lower the IP addresses.
Debo, I have a question, please.
Yeah. Mhm.
And what are the differences between a high IP address and a low IP address? I mean, what impact does it have when you have a
That's a good question. If you're creating an application, for example, I'm creating an application right now on the job that I'm going to create Databricks platform for my company where I work, right? I'm going to deploy Databricks platform for the company. And because we have about 200 users that'll be connecting. Not 200, no, maybe about 80 users that'll be connecting. We don't want to go to 6/16 IP address, VPC, because that's too many IPs. So I've decided to go to /20 VPC. So our VPC that we're going to create is going to be, our custom VPC. That's a good question. 172.31.0.0/20. That's going to be our VPC that we're going to create. Then now, this is our VPC. In this VPC, we're going to create two subnets. We're going to create 172.31.0.0 /24. They're going to give space. This /24 has how many IP addresses? 256, right? They're going to give some space. We're going to create 172.31.0/24. So this gives us another 256. So I'm going to use these two subnets, deploy our platform, and so we're going to end up having 512 IPs available for that application. But the application is internal to our company. So everything we're going to do on that platform that I'm about to create with Terraform, I'm going to deploy with Terraform, is going to have 512 IPs. But we're only having about 200 users. Because we have 200 users, we also want to double and then leave some more space. So we don't run into a problem called IP exhaustion. IP exhaustion is a real thing. You don't want to run into IP exhaustion. It's a depletion of available IP addresses for connected devices where you don't have any more IPs. You run out of IPs. So we're avoiding that. So for this platform that I designed it, I choose /20. I already have the list of users that are going to connect to the application. So it's about 200 users. So I said, let's go 512 because we're going to double. We're never going to run out of IPs. In the next 5, 10, 15 years, no matter how the company grows, we're not going to run out of IPs. So that's the impact of having a high IP and not having a high IP. It's a custom application that we're building or designing called Databricks. Go ahead. So you don't have to worry about exhaustion. So why did we give us .16 here? You want to give it .16 because from 172.31.0.0/24 to .16, you have 256 IPs in between. You see what I'm saying? In between. Same thing here. We're done with our custom example. If you want another 256 IPs, right? What would you go to? 172.31. What? Give me a number. What would you go to if you want another set of IPs?
32.
32. There you go. You did even numbers, right? You guys did prime numbers, even numbers in primary school. /24. You have another 256 IPs. So now you have 3 subnets, right? This is a subnet range. This is called a subnet range. Subnet range. This is a block, the VPC subnet range. Okay, they say, oh, Kwasi, Kwasi, go to the existing custom VPC that is 172.31.0.0/20 and create another VPC for us. Create another VPC for us. What do? You go in and create another VPC. How many IPs you guys need? We need 256 IPs. What subnet would you create? 172.31. What? Come on, guys. It's easy.
48.
No.
64.
64. Thank you. It doubles.
Oh.
It doubles. That's it. It doubles. Do not make a mistake. This is the most important thing in VPC, guys. I'm happy you guys got it so early. Okay. Sorry, guys. Sorry, give me 1 second.
Sit down. I know you're excited. There's Mitch. What about you guys? Who you picking tonight? 7:30, Ohio State.
Hey, Snap. My name is Yolanda Renee King, and I'm the only granddaughter of Martin.
Sorry, or blending. So, now they say, oh, create Isabel, Kobe, Tolu, create one more subnet. What will the range be? 170.31 dot what?
128.
Dot 128.0. That's it. And that's 256 IPs. This architecture here will be done by an architect. And then the architect will come on a call like this, share their screen, show you the Lucid chart, and you guys discuss this. This an amount of stubbornness only when you have a huge application. I will not advise that you create it. Guys, IPs are running out. IPv4s are running out in the world. The world has too many devices now that IPs are running out. So please, please, please do your due diligence and only create the subnet or the number of IPs that you need. The SREs I spoke to last week were telling me, oh, Debo, are you sure we really need 512 IPs? You know, that is, it's too much. No. I'm like, guys, the company is going to grow. Okay. It's an insurance company. We're growing. People are buying insurance and everything. We need these IPs. We're going to get more customers. We're going to have more agents that sell insurance. So please, let's create 512 IPs. Okay. If one subnet goes down, and we're running high availability in our application. If one subnet goes down, only one subnet is available. And how many IPs the subnet has? 256 IPs, 256 IPs. How many users do we have? 200 users. So 56 is left for what? It's left for you, the SREs, to connect, other devices to connect, other instances to run. So it's a safety mechanism that I created here for this application. Okay? When you complain to the architect that, oh, this is too much, give them a reason why. Give them a reason why. Okay? Okay. Any questions?
What happens when the IPs run out?
Applications stop working.
Hmm.
Yeah. When IPs run out, applications stop working. Completely. And
How can I know that it's running out?
how can you know?
Yeah.
You're unable to connect.
No, I want to say before we notice that it's out. You cannot monitoring.
No. You cannot monitor it, sorry. You cannot. I mean, you can. There's something on EC2. You can, the network team will know. You can see something called what was it called? ELB count. Number of connections, requests, or health instances are still the last load balancer. You can monitor it. Sorry, I misspoke. You can monitor it. Number of request counts coming to the load balancer. And if the requests are not responding, if it's not responding yes or no or whatever, then you don't have enough connections. But yes, you can monitor it. The networking can monitor it. Okay, or you can just type up how to monitor IP exhaustion, and that's it. Boom, it'll give you. I'm teaching you guys how to catch fish, right? Active connection time count, so you know how many devices are connected to the load balancer. Active connection count, you see the number, the sum total, right? If you know your load balancer or your subnet only has 256 IPs and you see 251, then you're in trouble, right? Maybe you have created an alert if it goes above 250 to ring a critical alert, and you have to disconnect devices, or the easy way to disconnect devices is to pretty much just restart the server, right? Every connection will drop. So, I was connected, I cannot connect. They're like, how many times did it connect? You can reach it out to them. Some users connect to the same application 4 times. So they have 4 active connections. There's one person. You see what I'm saying? So you have to create those alerts with internet to monitor those things and say, hey guys, we have a new system. You see, you have consumed LCUs and all these things, right? Mitigated host counts, all these things, you can track them. Load balancer, 500 error counts, right? 400 error counts from the client side, from the server side. You can have all these metrics tracked. When you say new connection counts, so new connections that are the ones that are connected today, right? Rejected connections. You can see what connections are rejected. You can see how many requests are there. So all these things are you guys, every company decides what is important to them, it's all based on the application and how the application serves the users, right? It's all based on the application. So you guys decide you guys decide how you want this to go, right? So that's a good question that you asked. So that's any questions on this VPC and stuff, right? The subnets. Again, a single subnet is attached to what? An availability zone. So this subnet that you see here can be US East 1A, dash 1A. This one that you see here, US East 1B, and then US East 1C, and then US East 1D, and then US dash East dash 1 A B C D E, like that. And what will be the next one? What will be the next subnet? 172.31, sorry, .31. Dot what? Was that?
256.
256.
Yeah.
Double it.
Unfortunately, the last IP address is not used, so it's 255. That's 0. Let me show you guys what the reserved AWS IPs is in the documentation. So reserved. Where is it? Reserved. The first IP address, the first 3, sorry, and the first 4 on the last IP address is reserved by AWS. So 255 is reserved by AWS. So the first 4 IP addresses, the 1, 2, 3. Let me go back. Let me not confuse you guys. So in this subnet now, like this, in this subnet here you see, your first IP will be what? 172.3.1.1.0. That's your first IP address. That's your first IP address in this subnet. So you have your VPC, you have your subnet, then you have your IP address. The IP address lives within a subnet. The subnet lives within the VPC. You see the hierarchy? And a subnet is equivalent to an availability zone, while a VPC is attached to a region. This is a US East 1 region. This is a region, this is a availability zone, and then this is your IP address. This is your first IP here. It doesn't have a slash because it's an IP address. It doesn't have a slash in net mask. It's just 172.3.1.1. What will be your second IP? One 172.3.1. Dot what?
.2,
Dot 2.0. Thank you.
0.
That's it. You go like this until when you get to 172 towards the end, dot 3.1 dot 254.1, because you cannot use 255 because it's reserved. Right? That will be, and then from here now, you go now to, from here now, you go now to 172.3.1 dot 2. Sorry, this is 255. 255.1, and then 255.255. This is the last IP address in this subnet. This is the last IP. 255, because if you look here, 255. Network broadcast address. We do not support broadcast in the VPC. Therefore, we reserve this address. It's reserved for AWS. The first IPs, this one, .001 is reserved. 02 is reserved. So if you come here, what are the reserved IPs for AWS in this VPC? 172.3.1.0.1 is reserved. 172.3.1.0.2 is reserved. 172.3.1.0.3 is reserved. 172.3.1.0.4 is reserved. What's the last IP reserved? 172.3.1.0.255 is reserved. These are the reserved IPs by AWS. This is what AWS used to connect to your account and manage your account and charge you a bill every month and all those things, and manage all the resources, the EC2 instances, the IAM roles. This is what they use to manage your account. 1, 2, 3, 4, 5. So when you create a subnet of /24, how many IPs do you have? It's an interview question. How many IPs do you have? Come on, guys. Come on.
256.
Okay, good. How many usable IPs do you have?
Hmm.
252.
Huh?
252.
No. What's 256 minus 5? 5 are reserved. 5 IPs are reserved. How many?
Okay, 251.
There you go. and this is the correct answer in the interview.
Mm.
They will trick you and ask you, wait, create a subnet of /24. How many IPs do you have? You say, well, it's 256 IPs, but there are 251 is usable in AWS. That's the answer. That's the interview that they'll interview. That's how they'll trick it.
Is there a way on how to calculate it, or you just have to calm the numbers? Like you said 256, like you said for 24, the number of IP address is 256, including the reserve one. So apart from the calculator that you just showed, how can we calculate it ourselves?
You
Or
just
it
know
is
off head. You just know. I
just
just
have to
off head.
know it. Okay.
I honestly, you're right. I crammed it. I know that S/20 will give you 4,096, but only 4,091 is usable. This /24 gives you 256, but only 251 is usable. A /16, VPC gives you what? 5,536. But how many of this is usable? 65,531. You just must subtract 5. In this VPC, it's 256. How many IPs are usable here? How many usable IPs are here in this subnet? Hello? Am I here? Am I there? Can you guys hear me?
251.
Also, is it 251 also?
41.
Yeah, 251.
Yeah, yeah.
In this subnet, how many IPs are usable?
Same 251.
Same. That's it, guys. You got it. Wow, I'm so excited. You guys understand VPC. So you have to know number of IPs in that subnet and number of usable IPs, which is very easy. Amazon has reserved 5 IPs because they use this to manage your accounts. But again, these are the number of IPs that you have to use. You can use 251. So in my project that I created, I really don't have 512 IPs. I only have 250. I only have 502 IPs. 502 IPs that are usable. Usable IPs. Always use the word usable, so that because some networking guy who doesn't know AWS, who is interviewing you but doesn't know AWS, will start saying, "Oh, you're wrong." He will tell you that /24 is 256 IPs. You're like, well, yes, you're correct. It's 256 IPs. But in AWS, /24 network is 251 usable IPs. Usable IP addresses. Okay? So, yeah. Okay? So, how many IPs usable 251? What is your first IP here? Somebody tell me. 172.31. What?
.255.
Oh. Okay, let's start from the beginning. I made a mistake here. I take that back. 172.31.0.0/24. In this subnet, what will be your first IP address?
One 172.31.
Mm-hmm.
.1.0.
No, that's right here. See. Right, see.
172.31.
Mm-hmm.
Dot.
Yes, keep going. .0.0. .0.1.
Okay, this one is included. Okay.
Guys, in the
Oh.
IP address, the IP address takes the form of the subnet. The subnet takes the form of the VPC. The only difference between this VPC CIDR block and the subnet CIDR block is the net mask, which is /20 to 24. That's the only difference. You have 4,096 IPs in here. And then if you want to break it down into subnets, you take this 4,091 and you break it down to 251, 251, 251, 251, 251, 251, like that. However, 251 times 6 might not give you 4,091. If you wanted to make the subnet smaller, that means you want to have 128 IPs in each subnet. You will not double the third number here in this octet. This is called an octet. You don't double the 10 number, right? You go from 1731.0.0, 1731.8.0, 171.16.0, 171.28.0, 121.48.0. You go by 8, you can jump by 888. In this case, we're doubling it because we want our 256 IPs, one larger subnet. These are larger subnets. If you want smaller subnets, you only go up by 8. The smallest number that you can go up in a subnet is by 8. What do I mean by that? If you want smaller subnets, this is how your subnets would be 172.31.8.0/24. It will show you that it will give you 251 IPs. But when you go ahead and create another smaller subnet of 172.31, sorry, this is supposed to be 0 here. That's the first subnet, right? .0, .0.0. And then 172.8.0/24. It can give you 251 IPs. But it will only be up to a certain number here because there's an 8 here. So when you start using this subnet, you can only go up to where this begins. It's a smaller subnet because it's a .8 here. It's not a larger range. And then the next one will be 172.31.16.0/24. And then the next one is what? What's the next one?
.32.
No. We're creating smaller subnets now. Smaller.
Okay.
Smaller subnets are smaller. While this one right here are larger.
Does it mean we are adding 8, or is still double?
Tell me. It's an interview question. You tell me. Look at it. Look at it. Look at the calculation, guys. Look at this side on the left side. Look at this on the right side. What are you supposed to add in the next one?
24.
24. It's easy. It's really, really easy. It's easy, right? And in the next subnet, what will it be? 172.31. What?
32.
Thank you. That's 0.
But on this first one, you said that we double the numbers. But it means that here, instead adding 8
No,
to the numbers.
because here is a large subnet. This is a large subnet means that you want to have many IPs and you don't want to have a range. You don't want to have too many. You want to have a conflict. You don't want to have a conflict.
Mm.
It makes sense? You don't want to have a conflict.
Okay.
Yeah. So these are smaller subnets, right? Just like that. You can go from 32 to 40 to 48 to 56. You can keep going small. So you have many subnets. This is when you want to have many subnets, but you only want to use small number of IPs in here. Here is when you want to have large subnets because you want large number of IPs among ranges. That's what this is. So your first IP here will be what? 0.1. Your second IP will be 172.31.0.2. Your third IP will be 172.31.0.3. Your fourth IP will be 172.31.0.4. Right? What will be your fifth IP? What will be your fifth IP?
.0.5.
What will be the sixth IP? Number 6. 172. Somebody's read the whole thing. You don't want to. You have to practice calling it as I'm calling it there.
172.31.0.6.
Among all these IPs, which ones are usable?
Transform .5.
No, Isabel, don't be lazy. Don't be lazy. Come on now.
Okay, 172.31.0.5
And
172.31.06.
no,
Dot
don't.
0.6.
Yeah, it's my mistake.
Omitted a dot.
Thank you. That's the spirit. That's how I want you to tell the architects. You omitted a 0. Right? Architects, we get feedback from the engineers a lot. So this, you have to use this word. You're an engineer. You have to call these words out. 172.0.0.0. You have to, when you guys have a capacity planning meeting, when you're doing capacity planning, you are when you're doing capacity planning, you're literally planning the IP addresses that you're going to use within the company and all these things, right? You're planning like the layers and all these things, right? So that's your first IP addresses that you use. Here, what will be your first IP here? Let's do this exercise. I like this exercise. Forget about the theory. Once you understand this stuff, you understand VPC. What's your first IP address here in this subnet? Knowing that this IP address takes the form of the subnet, and the form of the subnet, the subnet takes the form of the VPC. So in this case, what's your first IP address here? What's the first IP?
172.31.16.1.
Hey, I'll clap for her. Perfect. That's it. Okay. Give me the first usable IP.
173.31. 172, sorry. 172.31.16.1. .5.
Boom, 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 boom. You got it. You have perfectly understood VPC. That's it. Who wants to give me the seat IP? Somebody else.
Where?
Go ahead. Kobe, give me the seat IP.
172.31.16.6.
That's it.
Yeah.
That's it. That's literally IPs. That's how IPs are generated. So when you see your EC2 instance has an IP address, that's where it came from. It came from the subnet. It came from the subnet. Literally came from the subnet, right? What's the first IP in this one? Or the first IPv? Dot what?
32.
There you go. Dot.
1 for the reserve.
Yeah. What's the first usable IP? .31.32.5.
.5.
That's the first usable IP. Same thing here. Tolu, are you here? You're very quiet. 170.31.64.
Yes, I'm in.
The first IP base reserve. And so you have the first IP will be 172.31.64.5. And that's it. Okay. And so on and so on. That's it. That's pretty much it. Okay. Any questions on IP address? I know it's a little bit confusing, but I think you guys got it. It's VPC, subnet, IP address. That's the hierarchy. You create a VPC, you specify this range. Then from this range, you create a subnet. This subnet is inside of this VPC. And then from this VPC, you now have IPs. Your EC2, when you create an EC2 in this VPC, in this subnet, or in this VPC, your EC2 instance will take one of these IP addresses. And it would randomly take any of them. Okay? On that being said, let's log into AWS.
I have a question.
Go ahead.
Please, can you go back?
Yeah, 1 second. Let me log into my account. So, yeah. What's your question?
Yes, on that subnet, what would be the last IP address on the first subnet?
This one?
Yes.
A good question. Who wants to take that question? The 172.31. What?
Is it still
0.255.
255?
Yes, it's the same.
Okay.
Yeah. What's the last usable IP? One seven two
172.31.0.254.
Yes. Yes.
Mhm.
Perfect. So .01 is not used. .02 is not used. .02, 04 is not used. So it means that we only can use .05, .06 all the way to .04. If you add it up, it makes what? 251. Okay. Now it makes sense. That's it. What's the last IP here? Sorry, here. This one. Let me ask a tricky question. What's the last usable IP in this subnet? In this particular subnet here?
It will be long. 172.31.128.254.
There you go. You got it. You're officially a
Okay,
VPC expert. You've officially become a VPC expert. Guys, if you want to learn more VPC, I think you should contact Isabel.
Not so.
She's officially a VPC expert. She's just understood it so much. Okay, let's log into our accounts. Let's create VPC and then we'll call it a night. I'm starting to get congested again. I need to take medication. And guys, I need to update your resumes, right? I haven't done so with everything that we've learned so far. Please just be patient with me. I have been sick for 2 weeks now. This flu's not letting me breathe. As soon as I feel better, I might not work tomorrow actually. As soon as I feel better, I'll be able to set up and do it. So we're going to log into VPC, go to VPC, and I'm going to click VPC. I'd not even go to the theory because I just feel like the theory is just a bunch of words that not very important. Let me pause recording while everyone logs in. So there are many ways to create a VPC. On the job, you will use Terraform. Okay, you didn't tell that in the beginning. Yes. Unfortunately, the job wants you to know how to use Terraform, which is going to be something like this, right? And Terraform is very easy, right? You just go online, you just go create VPC Terraform. And that's it. VPC Terraform, you just copy this block and you put your starter block in there and you run it, and that's it. You create a file called vpc.tf. TF means Terraform. You put this block in here, and that's it. You create it, you give it a name. You can say Euphoria underscore VPC, and you put your VPC block, and that's it. Create VPC, done. If you want to create subnets along with the VPC, you come in here and you go to VPC subnets. But we'll do that some other day. Okay, I want to show you. It's very, very easy. That's it. That's a block you run. That's your tags. But for now, let's create a VPC to the console, which is here, right? You can come here. So we're going to click on this orange button, create VPC. And we want to create VPC and more. You don't want to just create an empty VPC. You need to create a VPC and more. So you show you USS1A, subnet, everything. It will show you, it will preview how things work. As I told you guys, a VPC leads to a subnet has a route table, and the route table has connections, okay? So this is pretty much a network structure. You can take a screenshot of this and keep it for yourself. See? I'll put this in the chat. Okay. So we can give it a name. Projects underscore, or you can give it your custom name. Euphoria underscore VPC, or dash VPC, whatever you want. So like I said, right, there are three classes of VPCs within a AWS, right? You have where is it? You have a class A, class B, and class C. You was going to say class A first, but again, you can use the class A. Let's do the class A. In fact, let's do all three. We're going to create three VPCs, one with class A, one with class B, and one with class C. So class A is right there already, 10.0.0/16. You can see here it's showing us 6,536 IPs, but we know that only 531 are usable IPs. So we don't want any IPv6 address. All our IP addresses are going to be IPv4 addresses. Tenancy is default. Number of availability zones that you want means how many subnets you want. A subnet is equivalent to an availability zone. A subnet is equivalent to an availability zone. I'll say it again. A subnet is equivalent to an availability zone. If you want 3 availability zones, let's choose 3 availability zones. If you want to customize, you can choose different customs. Let's keep it simple for now. Let's choose 3. US is 1A, is the first availability zone. US is 1B, is the second one. US 1 is the third one. Okay. Number of public subnets. You can have 3 public subnets. And 3 private subnets. If you want to customize it, we can come in here and customize it. For now, we're going to just leave it a default. So 3 public subnets, 3 private subnets. Leave it at guys. The number of public subnets that you add to your VPC. Use public subnets for web applications that need to publicly accessible over the internet. The number of private subnets add to your VPC. Use private subnets to secure back-end resources that don't need public subnets. NAT gateways, none. VPC endpoints, none. Okay, keep it none. And then enable DNS host names. Enable DNS resolution as well. What does this mean? Meaning that we create a domain name host name for our EC2 instance. Okay, is everybody here? Everybody here with me? I did not touch, I did not type anything, I just left the default. 3 availability zones, 3 public subnets, 3 private subnets, NAT gateway none, VPC endpoints none, create VPC. That's it. And it's creating everything for you. Okay?
Mhm.
So the VPC is creating. When it's done creating, we can view it. Okay, so that's pretty much it for VPC. It's very easy to create, right? And you can see here, default VPC no, means it's not the default VPC. Block public access is off, right? You can see the VPC has a main route table. Sorry, a main route table. This is the route table here. If you click on this route table, the route table is empty. There are no routes in the route table. It's empty, right? If it's empty. For route tables, if you look at the route table, It's empty. Go back to your VPCs, Euphoria VPC. Click on route table. It's empty. There are no routes in there. Okay. So that VPC is not usable because there are no routes in there. You cannot, there's no internet gateway, nothing in that route. Okay. So let's go back to your VPCs. Let's delete that VPC. And delete the VPC. So you delete everything about the VPC. I'm going to create. So I didn't tell you guys, by default, you're only allowed to create 5 VPCs within a specific region in your account. So if we create 2 more, we'll have maxed out. We'll have, this is the default VPC. And these are 2 VPCs. So we can only create 2 more. You can only create 5 VPC within the region within an account. That's the maximum. Because as you know, IPs are not resource are not unlimited, right? So they're limited. So they max it to 5 VPCs within an account within a region. So for US is 1, you can only create 5 VPCs. For US is 2, 5, but within your account. Okay. So let's create another one. Create VPC. Ohio State is destroying Notre Dame. Right. It's not even close. 21-7. So we're going to create another VPC. We're going to call this Megatron. Dash VPC. Megatron. Dash VPC. We want to change the SATA block. We want to create a VPC that have 4,091 usable IPs. What? And we want to use a 172.31 SATA block. What range are we going to use? Come on, someone tell me what range the VPC we're going to use. We want the VPC that is going to give us 4,091 usable IPs. Come on, guys. .0.0/20, right? 4,096, but 4,091 is usable. Okay. 2 subnets, 2 availability zones. One to customize it, one it to be. US is 1D and US is 1F. You can customize it. Okay. 2 public subnets. Let's customize it. So for our public subnet, 1/24, and then we also want it to be large. So we're gonna make this a .16. That's 24. And for our private subnet, we're gonna make it large as well. .32. And then here we're gonna make it a .64. Is everybody here with me?
Yeah.
So what we did when the whiteboard .16 .0.0/24 .16.0/24 .32.0/24 and then .64.0/24. No NAT gateways, no VPC endpoints. And you can give it a tag. You can give it a tag here. You can call it environment. Dev. Development environment. Is everybody here? Everybody's able to create 2 public subnets and 2 private subnets. So we'll have 4 subnets. Okay. This is a custom VPC we're going to create now. We're going to create a custom VPC now. It's 28-7 now. This game will end like 75-7. I don't think they'll score again. Ohio State is just too good. So is everybody here? You have 2 public subnets. Your public subnets they have the lower numbers, 0 and 16, while your private has the higher numbers, 32 and 64. This is the best practice way to just keep track of things. So if you see an IP address that has 172.31.32, you know, oh, it's private. But that's only if you created it, or that's what you guys have agreed within the company. Some companies will use the lower numbers for their private and the higher numbers for their public. So on your orientation day or when you're going to training, they'll tell you whenever you see a lower number in the IP address, know that it's public. It depends on the company. In my experience, what we do is we use the lower numbers for public subnet, and then we use the higher numbers for the private subnets. Any questions here before we click create? Create VPC. Uh-oh, look at that. This is what I wanted us to see. Look at that. It's filling. Why is it filling? Hello? Are you there? Why is it filling, guys? Because there is what? An overlap. So how do you fix that? Because it's a large subnet, it's a large number, you expand it like that. And now it creates. There is a space in here. Retry. So there is this, the first subnet 172.0.0. This one cannot create because it's already been used by the default VPC. I'll go show you. This is good. I wanted to show you an error so that you can have experience with this. Take note of this number 172.31.16.0 right here, right? If you go to your VPCs, look at the default VPC. Look at the subnet of the default VPC. Where are your subnets? One of these subnets here. You see? This one's created while it created. Why did it say it failed then? It created now. No, we did it /24. Hold on 1 second. Megatron VPC. Did it create? Megatron. Megatron didn't create. Let's go back. VPCs are more. It's still there. 0, 16, 32, 64, 10, 11, 1. Create. So some other thing is using this range. That's why it's not creating. So we can go back and we can, something is using this range here. So we're gonna do,
No, I think it's because it's coming 2 times.
do I
Oh
have it
no,
twice?
is that not it down
No, it's not. Hold on.
16? I thought I saw something twice.
32, 64. It's large. I think AWS, they may have changed this because before you can create these large subnets. I don't think they're letting you create large subnets anymore. Interesting. So let's do this. .31.8.0 plus 24. Okay. They don't want you to create large subnets anymore, guys. You see this? I didn't know myself, right? Because I'm not an engineer. So now they want you to create small. Remember I will talk about here? Remember this? Large subnets and small subnets. Small subnets are the ones that have the 8 and 16, right? Large ones are like 0 and 16 and 32. They're slowly changing. They don't want you to create large subnets anymore. They're allowing the 8. So the next one will be what? 172.32.31.16.0 plus 24. Well, no. They don't want this, they don't want this number, this particular number.
That I don't know if wait, the number of private subnet is not supposed to be 4 rather than 2 because we are creating more than 2.
No, right here. 32.
Okay.
1 and then 172.31.2.0 plus 24. They've changed it, guys. So now, yes. So now this third number here has to be under 8. I see AWS is really rationing IPs nowadays. No wonder they're saying we cannot create no more VPC in that account. Interesting. I just learned something new today. I see, because last week we had a meeting. They told us that we cannot create a new VPC in our existing accounts because there's not enough IPs. I see why now. Amazon will not let you use anything over .16 because it gives you a large subnet here. Now they're making you use smaller subnets. They're forcing you to use a smaller subnet and stay within a limited number of IP addresses. You see that? 0812. So it means if you want to add another subnet like this, you'll be like, hold on, let's create this first. We'll do another exercise again. Let's create VPC. And it creates. This is a new thing. Amazon has really scaled down. And that's it. It created a VPC called Megatron with a smaller amount of subnets. Okay. Because like sometimes architecture, the SREs never complain. I'm like, they should figure it out. Right? So if you go to the route table, it's empty. There's nothing. So we cannot connect to this VPC. So we have to create a route table and call it Megatron -RT. RT means route table. And select our VPC that I want to attach it to. Attach it to our VPC. That's the name of it. So we create a VPC, custom VPC, you have to attach a route table to it. When you attach a route table to it, which is like attaching your router to your network, you'll see this destination in here, this address in here. Now, this route table is private, but there's no connection to the internet. If you want to connect internet to this VPC, you have to go create something called an internet gateway. So let's create an internet gateway. Oh, we already have one right here. See, Megatron VPC internet gateway. But to create an internet gateway, you just come here and create an internet gateway, give it a name, and create it. It's that simple. And then when you create it, you attach it to the VPC. So in this case, we have one. We need to attach it to our VPC. So we're going to select that, go to actions. It's already attached to the VPC. Okay. See, attach to VPC, detach VPC.
So when you create VPC, it automatically create the internet gateway.
If you
also.
create a VPC, how we just created it on the dashboard from the console, it automatically creates a internet gateway for you. Let me go back and show you something. Create VPC. We're doing VPC and more. Because we choose public subnets too, it automatically created the internet gateway for us. If we choose public subnet 0, it will not create the internet gateway for us. You see that? Because we choose public subnets 2, it automatically created an internet gateway. Okay?
Okay.
So when you create an internet gateway, it automatically attach the internet gateway to our VPC, Megatron VPC, right here. Okay?
Mm-hmm.
Good. So now we have that route table that I've created called Megatron route, but the route is empty. Okay? You have 1, 2 routes here. We have 4 routes. Each subnet has its own route. So we want to make this route table called public. We want to make this route table a public route table. So we're going to open up that route table. And boom, you see in here is the internet gateway already attached to the route table. In our next class, we're going to learn how to create a custom VPC. And we're going to create things customly or manually. And then we'll be able to practice more. But because you created this VPC manually, using the dashboard, everything already creates for you. So it doesn't really teach you how to create individual pieces. This VPC Megatron has everything already done for us. The main route table, the route table, everything is there, right? So we can go ahead and delete the VPC and delete the VPC. I'm going to do one last one, which is class C. We're going to do class C. Using this 192.168.0.0 class C and create a VPC. Okay. Now, let's create one more VPC. And we're going to call this Euphoria. And we're going to do 192.168.0.0/20. And 2 AZs, 2 subnets, 2 prior subnets, none. If you want to look at it, you can expand it. If you want to see smaller subnets. Public subnets are lower numbers, private subnets are higher. So whenever you see a 192.168.8.1 or .5, you know that it's a private IP address. And that's it. Create VPC. And you see all these things create for you. Create internet gateway, attach internet gateway, create route table. As everything is done for you. But with Terraform, we'll do all these things manually. Or we'll write the script for it. I'm going to give you the exit script. This image. Okay. So on Wednesday, we'll learn more VPC and then we'll begin Terraform. And that's it. Continue your VPC. When you're done, please delete it. Delete your VPCs. Do not delete the default VPC. The default VPC is this 172.3.1.0.16 and doesn't have a name. Do not delete that VPC. If you delete that VPC, your account is blocked forever. You're never able to connect to the account again. Only delete the VPC that you create. Do not delete the one that you do not create. You don't get charged for VPC. VPCs is free. You don't get charged for it. An exercise I'd like you guys to do is AWS VPC tutorials. Create VPC. Create a VPC only. Create a VPC using the CLI. Yes. Create a VPC using the AWS CLI. That's your assignment. Create a VPC using the AWS CLI. This is the steps. So it means you're going to create things one by one. You create a VPC first, then you take the VPC ID and create other things. Then create an internet gateway, create a subnet. This is documentation here. Okay? Any questions so far? And you have the notes, right? You can go to the notes and all this stuff. I just thought that it's easier to just do things, direct. So let's do a little quiz. Amazon VPC is a component of which AWS service?
Networking.
I think the answer is C. I don't think it's networking.
C.
Thank you. Amazon VPC allows you to
Option B.
Yeah, B.
Toby's like, yeah, let me wait for class to answer before I answer. So that's the default VPC. You can go to VPC. If demonstrate how to create a custom VPC, we've done some of that. What is attached to the default VPC? What is attached to the default VPC?
Option C.
The internet gateway is attached to the default VPC. Why would you create a custom VPC? I think the answer is B. I think the answer is B. That's my answer. Why would you create a custom VPC?
A.
A. I will say A.
I think the answer is B. Who also have the different answer? Kobe,
A.
Kobe is B, right?
I don't know. I mean, I don't think it's A, B. That would be my answer for me, but I think the right answer is A.
The right answer. Guys, they'll trick you. I have to trick you guys, right? To know to all these things. Creating a custom VPC allows you to customize your virtual network by defining your own IP address ranges, creating your own subnets, both private and public subnets, and strengthening your security settings. Okay. So on Wednesday, we'll continue with IP addresses. It's good. Let's stop here. It's a good place to stop. Any questions before we drop off? All right, guys. Good night.
Thank you. You too.
Thanks.